Oh, hi there. Thanks so much for showing up for your learning, everybody. So today, you're going to take your own note. You're going to use a blank piece of paper and take a note. I hope the note will remain useful to you in the future. The note I take here, I am going to stick on the D2L and label it 2.6 or wherever we're at in here. Your note, you might want to start with a title. When you're at university or college or where you end up, if your lecturer doesn't give you a title, you'll have to create one yourself. So you might leave a little blank there. We'll circle back to this and give this lesson a title. Okay? Today our goal is this. I want you to write this statement down in your own words. I can graph quadratics regardless of the form and use algebra and other strategies to create a very effective sketch. So either one of those statements would be good. Let's take a look at the different forms of quadratics and the things that they tell us. So, have a heading here. Call it standard form. Okay. Standard form looks like this. A multiplied by x squared plus b multiplied by x plus c. This is our standard form of a quadratic. We might have this written as equal to y or equal to f of x. That would be fine. And this one, you'll want this little note to remind yourself. We can always put a quadratic into standard form by expanding and simplifying. Regardless of the quadratic that you've been given, if it's factored form, vertex form, some kind of mixed up weird form, there are mixed up weird forms. We don't look at a lot of them. Like if I add two quadratics together or something like that, or multiply two lines or something like that. We can always get back to a standard form quadratic by completing expand and simplify. Multiply your binomials times binomials, distribute your terms, collect your like terms. The result of all that in its simplest form is standard form. So we can always get here, regardless of where we start. When you see a standard form quadratic, you want to be able to very quickly do the following. You're going to practice this today. You want to be able to quickly get the initial value. This is also called the y-intercept, synonym. And there's a value up there that will tell you the y-intercept. Just to remind yourself what that looks like, make a quick sketch. A little quadratic here, circle it. Y-intercept. This always has an x value of 0 because it's at x equals 0. That's the definition of that. And then we just go ahead and grab that c value, and that's where your y-intercept is. Very useful. One of our key points when we're creating a good sketch of a quadratic. We can get that from standard form. There you go. Okay. Another form for quadratics is factored form. This one looks like A multiplied by x minus r multiplied by x minus s. And that could be as y equals, or that could be equals to f of x, or what have you. Some quadratics are factorable. So we get to factored form by factoring. Pretty straightforward that way. And the information that factored form gives us are the roots. Or, in other words, the x-intercepts. And have your little sketch of your quadratic again, little random quadratic. Circle them, the roots. In other words, the places where f of x equals 0. You're going to solve this one. Okay? Actually, another thing you could add to your note up here is you're basically solving f at 0. You're setting x to be 0 when you're solving for an initial value or a y-intercept. But over here, you set y to 0, and then you solve for x. So the two roots in factored form are given by r0 and s0. So you notice that these are negative, meaning they're sign flippers. So you take the r out, you make sure that sign gets flipped. r0 and s0 correspond to the values of the roots. Very nice, very good. Okay. Another note for you about factored form. If the quadratic has roots but can't be factored using integers or rational numbers, the quadratic formula tells us the value of the roots. So you may want to have this down. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. You can't write this down too many times. I haven't written it down too many times yet, and I've written it down more than all y'all. So there you go. Okay. So the last type of quadratic that we might be given, I'll keep that up just in case you're still copying, is vertex form. Unlike factored form, but like standard form, vertex form here given by a multiplied by x minus h in brackets all squared plus k is equal to f of x. Okay. Unlike factored form, but just like standard form, we can always put a quadratic into vertex form. We can put any quadratic into vertex form by completing the square or by finding the vertex and just writing the form. There's a variety of strategies to find the vertex. The vertex is going to be, it's not necessarily at a place like x equals 0 or y equals 0, so there's not as straightforward of methods to go ahead and find it. First, we need to locate where the quadratic is having its vertex. In other words, find that axis of symmetry, and then evaluate the quadratic there to get the value of the vertex. So we're going to get lots of practice doing these three conversions today. A little sketch for you so that you have this represented. We're going to have this here as our random quadratic. Just go ahead and put that there. Circle the vertex and label it HK. So the vertex HK comes out of this form. Notice that one is a sign flipper and that one is not. So this tells us the vertex. There's our note. So this is your note on the three forms of quadratics. It becomes precious to you. You fold it up and put it in the book you're reading so that every time you're done reading for the day, you just look this over and remember the different information that the different features of quadratics can tell you. And now let me show you how we're going to practice. So using your whiteboards, we're going to complete practice by creating some random quadratics. I'm going to do 2 with you right now. I'll start one from factored form and one from vertex form. So I'm going to go ahead, just make this a little smaller, and get myself some dice. So I have a little handful of dice, or I use a random number generator that I carry around in my head. That could be my brain. And I'm just going to go ahead and roll these until I get what I feel to be our interesting numbers. Numbers that don't include a 1 today. Oh, what did I say about not including a 1? There we go, 6, 2, and 4. Okay, so I like these numbers. They're delightful. I'm just going to go ahead and dump them into this quadratic. So I'm going to say that this is 2, this is 6, and this is 4. And I need some signs, so I flip some coins. Someone tell me positive, negative, positive, or positive, positive, negative.
Negative, positive, positive.
Negative, positive, positive. Okay. All right, cool. So I might rewrite this quadratic just to have it be very clear to me. This is y is equal to minus 2 multiplied by x plus 6 times x plus 4. Okay? From this, immediately, I go ahead and get the value of my roots, which are minus 6, 0, and 4, 0. Okay? And then my minus 4, 0. And I go ahead and just put them onto my graph here, wherever I feel matches those values. Okay, so there's my 2 points. I got the roots down. All right, now I'm going to expand this and get it into standard form because I know that's going to tell me the value of the y-intercept. So I have minus 2. I'm going to leave that outside the party for now. X squared plus 4x plus 6x plus 24. Woo. And then I collect my like terms and multiply by that minus 2. So then I get minus 2x squared. This makes 10x, so that altogether will be minus 20x. And then 24 times minus 2 is minus 48. Okay? So I have converted the quadratic to standard form by expand and simplify. Now I go ahead and notice that this minus 48 corresponds to the value of the y-intercept. So that's way down there, let's say there, at the point 0, minus 48. And we've got our 2 roots here at minus 6, 0, and minus 4, 0. And the next thing that I want to do is go ahead and find that vertex. I can find the vertex by completing the square. I would complete the square from standard form and go ahead and complete the square. But people are looking at me like you're not too excited about completing the square because it's not your favorite little piece of algebra, and it's not my favorite little piece of algebra neither. Can anyone tell me, looking at the roots, where the axis of symmetry is?
-5.
Very good. So if we just visually look, we're going to already start being able to imagine this quadratic coming up here, hitting that root, turning around, hitting that root, and going down that way somewhere, okay? And if you look right in between minus 4 and 6, there is minus 5 equals x. That's the value of the axis of symmetry. So we can just evaluate this quadratic at the axis of symmetry. So let's do that. So this is equal to minus 2. I'm going to put something in there. Minus 20. I'm going to put something in there. Minus 48. That's the value of y, but I'm particularly interested in when x is minus 5. All right. So I'm just going to substitute in minus 5, which we know is the value of the axis of symmetry. That's the equation of the axis of symmetry, sorry, because it's dead smack in between the roots. And then we evaluate. So go ahead and race me. See if you can do that mental math or calculator faster than I do. It's fun. It's fun if you can beat me. It happens at 2. There we go. So we found the y value of the vertex, it's 2. And so that tells me that the vertex is at minus 5, 2. Cool. Let's put it on and label it. Boop. Minus 5, 2. There. Sketch of quadratic done. If I was asked to give this quadratic in vertex form, I would also write y is equal to minus 2, that's the a value, multiplied by x plus 5, because this one's a sign flipper, so I flip that one sign, plus 2. This is squared, however. Okay, there we go. So that's all 3 quadratic forms. I've used all 3 quadratic forms, and at no point did I need a table of values. The more I do these algebraic manipulations, which lead to an excellent sketch of my quadratic, the more the algebra that I'm learning is speaking to the graphing and my visual understanding. Visually, you all understand I throw a ball at you, it goes up and it comes down and it hits you in the hand. Okay? Most of you can catch a ball if I throw it at you. Connect that visual understanding to the algebra and you will find math starts to become quite intuitive and makes a lot of sense. And it's not like these weird arcane processes. Okay? All right. So next, another thing that we might do is create, I'm just going to get a fresh copy of that open. Boop, pardon me, this one here is a fresh copy. There we go. Another thing we might do is create a vertex form quadratic. So I'm going to roll some new dice. Where's my die roller? There it is. Roll some new dice. Notice I always need 3 variables when I'm creating these quadratics. Okay? There's always, not variables, coefficients. All right, fine. Let's just do one more here. Okay, that looks fine. Okay, so we will use this. Let's say we have 3. Oh, that's strange. Multiplied by x minus 5 squared. Actually, I want to flip that around. Just going to roll this one again. Oy. Yeah, there we go, minus 6, that's good. And we'll do plus 3. Okay, so rewriting this one, we are going to be interested in this quadratic. Y is equal to 3 multiplied by x minus 5 squared minus 6. Okay, so the first thing that I know is that this one has a vertex at 5 minus 6. It's very clear where the vertex is. It's just right there in the form. This one's a sign flipper, this one's not. So I go ahead and put that onto my graph, call it about there. 5 minus 6. It's a quadratic that opens upwards. I could use step pattern to graph this one, but then I wouldn't get the roots. Because this one, I kind of fudged my dice a little bit so that I would get one where I'm required to use a quadratic formula. First thing let's do, let's expand it to standard form and find out about the y-intercept. We're going to find that it's way, way high up. It's super duper high. Okay, which is fine. Okay, so what we're going to do is expand this one to standard form. Y is equal to 3 multiplied by x minus 5 multiplied by x minus 5. That's x minus 5 squared. Minus another 6. So that's equal to, continuing to expand and simplify, x squared minus 10x plus 25 minus 6. Before, and I have to do this in Bedmas order, so I've done the exponent first. I choose to do the multiply binomial times a binomial first because it's easier than multiplying that 3 in first. Now I multiply the 3 in. So I get y is equal to 3x squared minus 30x plus 75 minus 6. Aha! My c value is finally coming together. I now see that my c value is 3x squared minus 30x plus 69. So this is over here at 0.69. It's way up high. And then we keep going because we are now like on the road to having a very good sketch here, but we're anticipating that this comes up, goes like that, and goes up and goes like, kind of hits that point over there. Not a very good sketch. That kind of looks ugly, but hey, you can't sue me. All right, so next, I might attempt to get this into factored form. What's the first type of factoring I should always look for?
Divided by 3.
Yeah, I could factor out a 3. Yeah, which involves dividing it by 3. You're not wrong. I'm just being very fussy with the language I use. So this is 3 multiplied by x squared minus 10x plus 23. 69 divided by 3 is 23. Okay? And then I might say, well, I'm confident that this parabola has roots because I can see the vertex is down below the x-axis and the y-intercept is above the x-axis. So it must cross the x-axis twice. But for the life of me, I can't figure out a way to multiply to positive 23 and add to negative 10. You'll find 23 is prime. There's only one way to multiply it. It's 1 times 23. So if I do 1 times 23, I certainly haven't added to 10 in any possible way. So I need quadratic formula at this point. So now I go ahead and I'm going to switch ink. And I'm going to write down my A equals 1, B equals minus 10, and C equals 23 from in here. Okay? Ignoring that for the moment, because this is the simpler equation, it will still give me the values of the roots. And then I sing myself a little song. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, and then I just sub in and solve. X equals minus 10. Oops. Minus 10. I'm going to zoom in. Okay. Minus 10. That's pretty gross, pretty ugly, but whatever, we'll figure it out. Plus or minus negative 10 in brackets squared minus 4 times 1, which I'm not going to write, times 23. Cool. All over 2 times a, which is 2 times 1. So this gives us x equals minus 10 is positive 10. Plus or minus the square root of 100 minus 4 times 23. 4 times 23 is easy to do in your mind. Do 4 times 25 and subtract 4 times 2. So you got 92 there. All divided by 2. Okay, and so then I can simplify this even further. X is equal to 10 divided by 2 plus or minus the square root of 8 divided by 2. Oh, that's beautiful. I didn't see that. This is 5 plus root 5. Okay, so this is x equals 5 plus root 2. Yeah, plus or minus 8 on root 2. For now, we're just going to leave that way. I happen to know that that's equal to the square root of 2, but you don't know that. That's fine. We're just going to punch it that way. Root 8 on 2. There are the values of our roots. Okay? Notice that the negative b over 2a part, this part here, negative b over 2a, that actually gave us the value of the axis of symmetry. That gave us 10 on 2, which was 5. You'll notice 5 showed up very early in all of our stuff here. That happens to be this axis of symmetry where the parabola is. And then this here was minus root 8 on 2, and this is plus root 8 on 2. So the discriminant shows us how far apart from the axis of symmetry to go to find those two roots. So then the quadratic formula, that algebra, starts speaking to your visual mind, and you start seeing how these things map out on the xy plane, and it all becomes very intuitive. This visualization ability that you develop allows you to error check your algebra and notice problems when you have like, oh, you missed a negative or something like that. It shows up in the visualization and you start trusting your intuition. So it's very valuable to go to a high level in math, all of this stuff. So then we might evaluate that on a calculator just to get a good decimal approximation. So here we go, calculator. And I have 5 plus 8, but I take its square root, and then I divide by 2, and that gives me this number, 6.414. So this here is 6.41 comma 0, okay? And then I do the negative one. So I go clear. I say 5 minus 8, but I take its square root, and then I divide that by 2, and that gives me 3.58. So I'm going to go 3.59 because that 5 makes it round up. So this is 3.59 comma 0. There's my roots. There's my vertex. There's my y-intercept. I have an excellent sketch of this quadratic. Having converted it to all the different forms, I wasn't able to use factored form, but I was able to use your op, but my bud, the quadratic formula. So that is how you're going to practice today. You're going to roll 3 dice. You're going to create a quadratic that's either a random standard, a random factored, or a random vertex form quadratic, and use your different conversions to graph it. How many you do today is how you measure your progress. You can also use Desmos to check your work and see if the quadratics that you've graphed in fact match the graphs that you created. Okay, so phones are allowed to check your work with Desmos. All right, otherwise, thanks so much for showing up for your learning. Get practicing, everybody.